My name is Tilman Schröder. I'm the CTO for Automotive and Manufacturing at NetApp, so focusing on building industry-specific solutions with our NetApp technology. And I have the honor to be here on stage with Kevin. Kevin, why don't you want to introduce yourself to the audience?
Yes, so I'm Kevin Bakke. I handle solution strategy for product engineering and development, focusing on automotive manufacturing.
Great. And the problem statement for today's session is basically how can we, NetApp and AWS together, make product and engineering workloads in total, such as CAE simulation or PLM workloads, more robust, more cost efficient, and also higher performing. This is going to be like the overall value statement for the session. And we're going to go through it by case studies, so to show you the art of the possible, how integrating our technology can help you to build very robust and efficient architectures in AWS.
Excellent. So I'm honored to be here with NetApp and to share with you an extremely important topic in product engineering, but also beyond product engineering, into manufacturing, into service, and so on. So I don't think there's any doubt from an AWS perspective in solutioning. We've been focused on areas like migrating, modernizing PLM infrastructure, PDM infrastructure for companies to streamline and give more performant product engineering. Also, computer engineering and simulation has been key for our workloads, leveraging our high-performance compute, as well as VDI. So these have been all topics that we've been working on. But what I wanted to really share, if you go into the next slide, is the transformation that's happening in the industry, right? And it's really built on three different foundational pillars. One, most importantly, is an effective data strategy. And that's what we're really here to talk about, and how NetApp is delivering that for AWS and our customers. Next thing is going to be delivering a lot of the innovations that you're seeing out here in spatial, as well as artificial intelligence, generative AI. But again, all of that is built on an effective data strategy and data foundation. So we're going to go through some use cases to show how this is being delivered in the near term, as well as setting customers like yourselves, partners up for the transformations that you're all seeing throughout the show here. So hand it back over to our...
Yeah, so before we dive into specific workloads, first of all, let's set the context straight and articulate really what NetApp is, right? So we are an on-prem storage company that is very innovative in also now providing cloud-native storage in the AWS via FSx for NetApp ONTAP. And what does it mean? It basically means that for your data management and data storage, you can build true hybrid cloud solutions that don't need to be set up via yet another marketplace offering, but that are natively integrated as a gateway to your AWS setup. So our value proposition in a nutshell consists of three pillars. First of all, providing on-prem enterprise advanced storage. Secondly, providing cloud-native storage for file workloads in AWS, such as computer-aided design workloads. And thirdly, very importantly, building true hybrid cloud scenarios where we can distribute the load and data sets across different environments. That's like our value proposition in a nutshell. And with FSxN for NetApp ONTAP, this is going to be the service today that is enabling a lot of product lifecycle management workloads or computer-aided engineering workloads in total. So before we dive into the workloads, let's quickly really describe this concrete value proposition that we provide for product and engineering workloads. So as you can see here, product and engineering workloads have a lot of data management challenges, such as file management can be very complex, data access times can be very long and have a negative impact on the productivity of your engineers. And thirdly, right, the setup and maintaining of the infrastructure for those very mission critical and highly advanced workloads can be a hassle and very complicated. And those are the three things, and ultimately cost, obviously, whether it's directly costs associated to the cloud resources that you spend or indirect costs associated to the decrease in engineering productivity. And this is basically the value that we achieve for product and engineering workloads defined as PLM workloads, computer-aided engineering workloads, or even machine learning cloud bursting operations. And now we're going to deep dive into each of these case studies and show you how our customers use our technology to truly enable product and engineering workloads in AWS. So workload number one. Let's talk about product lifecycle management systems, right? We have this massive shift currently going on of migrating PLM workloads to the cloud. There are multiple reasons for this. First of all, right, cloud economics, that you want to benefit from the cloud economics. Secondly, innovative performance. You want to access the innovative services that AWS is basically providing on top of your PLM. And thirdly, right, you have a distributed network provided by AWS that you can leverage and also, don't need to maintain so much infrastructure in the end. So this is where we see a lot of customers using Siemens Teamcenter, PTC Windchill, or Dassault systems actually migrating their PLM to the cloud. However, when migrating to the cloud, you also need to think about a very robust data platform, right, to host those mission-critical applications. You want to accelerate the time that the engineers is actually accessing the data. To when you modernize the platform in terms of the cloud, that you do not have a decline in user experience eventually. So this is where we come and play and support you with a very strong service on the resource layer, which is the database and the CAD files for PLM applications, to make it across the value chain up to the engineer more efficient and provide the data set in a less time. Workload number 2, computer-aided engineering simulations, right? This is also a massive shift right now going on because the cloud perfectly fits for computer-aided engineering workloads because it's very volatile, right? So the cloud is not very static, so you can just consume your resources as you go via the cloud. So computer-aided engineering and HPC workloads fit quite well. However, again, right, sometimes you want to optimize the data access times and decrease the time to actually set up the infrastructure for those things. Also might want to optimize those things, those setups, in order to automate as many processes as possible, right? So here we again create significant value by integrating into your CAE service architecture design, storing your CAD files more efficiently, eventually leading to faster data access times and decreasing the time to actually run simulations in the cloud, to accelerate ultimately the time from it takes to research and to production, and enable you to have more iteration cycles, right? This is then the core value that we provide here. We also brought a case study, right? So this is not like a R&D project, but customers are really using it as of today and adopting this technology very fast. For example, Rivian as an example, they had the challenge that they needed to simplify their IT operations in terms of automation, and they also needed to accelerate, again, the time that it takes to open up the CAD files in the cloud for their PLM environments. They also had the problem that the dev test provisioning of those environments took 8 hours. And with our technology, we enabled Rivian to do it in just 3 minutes so that they could, first of all, fully automate the process and then provision those dev test environments in just a few minutes instead of multiple hours that the resources stand there idle. Eventually, the outcome were reduced infrastructure spend out of 2 reasons. First of all, storage efficiencies, reducing the overall resource footprint and the overall cloud spend. And more importantly for those workloads, decoupling from the compute and the storage together, right? So decoupling it to make the resources more efficiently distributed. In the end, that resulted in higher engineering productivity and obviously less cost associated to it. So this based on the example of Rivian, who were implementing CAE workbenches and also PLM migration, and how we actually enabled them those mission-critical applications in the cloud. Okay, let's come to the next workload. And before we come to this workload, I want to shift a little bit gears and provide to you some interesting insights from an Economist article that was published last year. And I think the headline is quite strong, right? So cloud is massively growing, as you can see here on the right-hand side of the diagram, right, in terms of budgets that are growing and more consumption that are going on. So cloud is growing, but there's also something, data center hardware and software, and what it shows, it's data center software and hardware, it's also here to stay, right? Because cloud has certain propositions where it makes sense in terms of agility, flexibility, scalability, but there are also propositions associated with on-prem, right, that are valuable, such as low latency applications or data sovereignty aspects. So hybrid cloud is currently very strong, and our technology, since we are natively integrated into the AWS console, we can be the gateway to actually enable those hybrid cloud scenarios on a storage layer. And what does it mean? It means caching data efficiently, synchronizing data automatically, tiering data back and forth across environments or across zones. And this is like the setup what we see also with regards to hybrid cloud, which can support you, for example, with IoT workloads, right? Where you have a shop floor, for example, that you want to connect to the cloud, or even autonomous driving workloads, right? Where you need to collect a lot of data and then you need to push it to the cloud in order to do innovative stuff with it. And that's the setup, and that brings us to workload number 3, cloud bursting, which is like a topic or feature associated to hybrid clouds. Cloud bursting, the definition basically means that you want to have access to resources, maybe from the cloud or from on-prem, very in an agile way, right? So you want to basically gain access to additional compute resources either from on-prem or from cloud or vice versa, or across multiple availability zones. And the technical feature that is actually enabling this concept of cloud bursting is basically flex cache or caching mechanisms, which you can easily and efficiently provide just the data that you need, not the whole data volumes of data, to the cloud in order to access it to the compute, run your simulations on top of it, and once you have the results, you have a bi-directional relationship to your on-prem appliances, where you can then just push the results very efficiently. Impact is that you reduce egress costs. Basically, you can fully automate the process, and you accelerate the time to actually provision the data then to the different environment that you are currently need. And yeah, so workloads that are use cases that are associated to this, I already said it, right? You can burst for computational fluid dynamic workloads to access GPU resources. As one example, you can also train your machine learning models, right? So because based on your data that is on-prem, you can train it in the cloud or vice versa, whatever you prefer. And what you can then also enable is associated to the inferencing part, not the training part. You can do RAGs, right? So push your data into the different ML ops tools and build your own RAG-optimized machine learning models with it. Yeah, so this is then workload number 3, and we also again have a case study associated. So especially in chip design, and EDA customers are heavily leveraging this technology. They are very innovative. What they are basically doing, or what they wanted to do, they wanted to decrease the operational burden to connect data on-prem to the cloud, right? And also what they had experienced were a lot of downtimes when they actually, bursted to the cloud to do the analytics part for the EDA design workloads. So what we basically increased was the business continuity. We automated the processes that you also have all the dependencies associated to your environments that you have on-prem, just bursted to the cloud, that you can directly don't need to set up any additional new hassle, but you can directly set it up and then run the EDA workload on top of it. And yeah, so this is based on the example of ARM, but there are many, many more EDA customers that are using the hybrid cloud bursting concepts as of today. And I think this is a very unique value that we can provide in order to balancing ultimately the resources across the environments, right? Distribute them more efficiently from on-prem and cloud, that you don't see it in separate isolations and data silos, but break those data silos and have a true hybrid cloud experience enabled by NetApp technology, for example. Yeah, so just to recap, right, crisp and short. So we have talked about different workloads now. Just to summarize, here's another workload, engineering VDI stations, right, which is also a very strong workload that we can cover in order to give the engineers the necessary engineering VDI stations to do the work on the analytics platform and those kind of things. So there we also have a very strong value proposition. In a nutshell, what's the message out of this is, right, if you build those really mission-critical applications for your business in the cloud, talk to us, use FSx for NetApp ONTAP technology right away, right, in order to achieve business continuity and also make your mission-critical applications very secure, protected, robust, and by the way, also save some costs associated to it, right? So it's just a win-win situation to make all those different product and engineering workloads just a little bit better in the cloud and ultimately reduce your time from research to production and decrease iteration cycles that you might have. So,
yep. if I may, just
Yeah, please.
to recap with what we started out with, right? So product engineering, data rich, right? We've got data in lots of repositories and lots of places, right? It's really about how do you effectively get that data in motion, reduce the friction of that data, leverage it, while still maintaining the control over your IP and your data through the processes. And hopefully what you've seen in use cases like we've shown here, right, is the ability of capabilities with NetApp and AWS to be able to effectively take that data and put it in motion and really monetize it, right? Get those key capabilities. And most importantly for me is building that foundation on these use cases to then go into all of the different use cases that you're seeing out there, whether it's generative AI, AI/ML, the spatial use cases and technologies. These are the things that are really going to unlock product engineering for manufacturing, for service, and all of the other workloads across your customer and across your operations.
Yeah.
Thank you.
So call to action would be, right, visit us at our booth. It's, oh, I forgot the number of the booth, but it's directly next to the coffee shop. So visit us there. Let's talk about those workloads. We help you design those workloads. We can help you size those workloads to make it as protected and as robust and as cost efficient as possible to make you innovate further and build super cool products as you all do. So, yeah, that's it.
Thank you.